So question 2 of the May 2018 AS Edexcel paper. So first part, we've got a quadratic here, x squared minus 8x plus 17. Now we're not being asked to solve a quadratic here, we're being asked to show that this quadratic is greater than 0. In other words, we're being asked to show that this quadratic is positive everywhere. And the best way of visualizing that is that if we were to sketch this graph, it would look something like this. That's really what a quadratic would look like if it's greater than 0 everywhere. So it's all about really this minimum point here. As long as that minimum point is above the x-axis, okay, so let's just draw another one. So this one over here, this minimum point is below the x-axis. That means there's some negative y values, okay. So we would want it to look like this first one, okay. So if we can find this minimum point and show that this y value here is positive, okay, then we've proved it, okay. And the best way, it's not the only way, but the best way really to find that minimum point is to complete the square. Okay, so we go ahead and complete the square. So we put half of the coefficient of x inside the bracket, and then we need to subtract off 4 squared. Okay, whatever this number here is squared. Okay, copy down the plus 17, copy everything really. Okay, and then we just collect our numbers together. So we've got this, so minus 17 plus, minus 16 plus 17 is plus 1. Okay, now when you look at that completed square form, okay, our minimum, the x-coordinate of the minimum is going to be 4. That's the number that would make this bracket 0. Okay, and then the y-coordinate is this number here, which in this case is 1. Now, if I just put that on the diagram, it's this. As you can see, what the x-coordinate is for the minimum isn't particularly important in this question. Okay, what we're showing here is that the y-coordinate of the minimum is 1, and therefore it looks like our diagram. I would encourage you to draw a little diagram like this in a question like this, because it shows that you understand what it is. Okay, maybe I would follow this up with a few words to say the minimum is at 4, 1, therefore that quadratic is positive everywhere. Just use a few words, okay? So moving on to part 2, it says if I add 3 to a number and square the sum, the result is greater than the square of the original number. We need to convert that sentence, that kind of English sentence, into some mathematical sentence, in other words, an equation, okay? So it says if I add 3 to a number, well, if we take x to be a number, okay, and we add 3 to it, it looks like this, and then square the sum. Okay, that's just good use of brackets. We square the sum. Okay, the result is greater than the square of the original number, so we put greater than the square of the original number, where the original number was x, and the square of it would look like this. So instead of being given an equation to sort out, we've been given some words that we need to turn into an equation. It takes a little bit of practice to be able to do that. Make sure that you can follow that yourselves, and maybe practice that. If your book's got some similar questions to this, then definitely practice doing that. Okay, now over to the algebra then. I'm going to square this bracket out, x squared. I'm going to get plus 3x plus another 3x. Okay, plus 9 is greater than x squared, and then you can subtract these two x squareds from both sides, so that leaves us with 6x plus 9 is greater than 0. Okay, take the 9 over the other side and then divide by 6 and simplify that fraction 3 times tables. Okay, x is greater than minus 3 over 2. Okay, so we've got this sentence. Now if we go back, we've done the algebra, go back and read the question. It says state giving a reason if the above statement is always true, sometimes true, or never true. Okay, so by doing the algebra, gives you an idea of what numbers to pick. So if we pick a number that is greater than minus 3 over 2, okay, so if we pick 0, 0 is a nice easy number to pick here. If you look at this original equation, which is representative of the sentence, if we put 0 in there, we're going to get 3 squared on the left is greater than 0 squared, which is clearly a true statement. So it works for 0. Let's put that over here. 0, it's true. Okay, but our answer also tells us that if we don't pick a number bigger than minus 3 over 2, then it won't work. So let's pick a number that's less than minus 3 over 2. So let's pick minus 2. Okay, so we put that into this equation. Minus 2 plus 3 is 1. 1 squared is greater than, we basically get 1 squared is greater than minus 2 squared, which says that 1 is greater than 4, which is clearly false. Okay, so I just managed to pick a number where it doesn't work. Okay, so your answer to this question really is that the statement is sometimes true. Really what we've just proved there is by picking one number that works and one number that doesn't work, you're proving that it's sometimes true. So this is the final answer, that it's sometimes true. Again, you just probably want to write some words to explain which numbers that you've tried. Okay, but this really, by solving the algebra, it really tells you which numbers to pick. Okay.